Now, I'm also talking about computer-based math, but my talk isn't about really about curriculum or the vision that we have. This is a talk about software engineering and process engineering. And so since I've given up some of my time so generously, I'm going to skip through a recap of what the point of CBM is and talk about how we went about delivering on our initial project, the Estonia project. So most of what I'm doing here is in fact nothing to do with computer-based math. It's just how we happen to process the engineering and building of computer-based math, and so it's equally applicable in a computer-assisted maths environment. So our start point, we had some design specs from Estonia. They gave us carte blanche on the curriculum to design how we wanted, but we did have some design specs that we had to meet. And we had set out with a platform choice. Now, it was an easy choice for us to start off with. We decided at the beginning everything was going to be in computable document format. That was twofold. One, because we think it's a great format. And secondly, the more obvious one for us was we had a whole bunch of experts who know what they're doing in Mathematica technologies, and we don't know very much about all of the other possible choices for platforms for doing things in the web, and so we had the skills to call on. Imposed on us by Estonia was the requirement that it had to work in both Mathematica and in the CDF player. So we had to mix, obviously, some things if the programming exercises and totally open-ended things can't work in CDF without the ability to write, but those things that were capable of working had to work in both. And we also made the decision that we would do the whole thing in top-level code in the Wolfram language. We could have used our inside knowledge to force some of the front-end developers or kernel developers to add features, but we made the decision that we would not rely on any changes to Mathematica. So everything that we did is what you could do as a customer. There was no special inside knowledge allowing us to build what we did. So for the little time that I have, I wanted to go through 6 different things that we had to, key tasks that we had to design a software solution for. We had to create a content container, some way of delivering the material to the students. The CDF itself, we could just give a big folder full of CDFs, but we wanted to give some more structure and management to knowing where you were and being able to patch in different material. We had to build lots and lots of custom learning apps. Some of them very open-ended, right up to programming, some of them very closed and constrained. We wanted to streamline the authoring process. We had multiple authors, and we needed to make sure that, first of all, there was efficiency, but also that they were all building content to a common standard so that there wasn't a kind of, you turn the page and suddenly everything's ordered differently and styled differently. So we wanted to streamline that. We wanted to build some traditional things that are widely used in education, of the ability to do formative assessment, question and answer and feedback with the teacher. And we wanted to support, and this was required for Estonia, but is nothing to do with necessarily other deployments of CBM, to support teacher-led learning. It was still going to be a traditional classroom. But we also wanted to support collaboration, particularly in stats, where we wanted to be able to get data from the students and have them then work immediately with the data they've collected. So let me go through each of those in turn. So the content container had to have some fairly basic things. And so none of this is rocket science here. We had content navigation. We wanted to be able to control settings for preferences, like what language you were in, and account management for the collaboration. So if I get up the computer-based math here, this thing here is just a CDF, slightly disguised. It's just a 2-column panel with a scrollable pane and some of the window furniture turned off. And this is the main interface that lives in the palettes area in is how students start the material. And some of the settings are automatically written to a preferences file. So if I switch to Estonian, next time I start in this user profile, it'll start in Estonian. I better go back to English, because even after 6 months on this project, I can't speak any Estonian. And then we've got a set of modules, and then we also have other content called primers, which is sort of key mathematical things that are given in a more traditional abstracted way, and they form an anchor. When you see a concept like causality being referenced in 2 different modules, you needed a common place to say, I've seen that before. And the idea is you launch things from here. So if I go back to contents here and pick a module, let's say, how many words of Estonian do I know? You've already seen this. We've got, again, some basic content container, the lessons here in a slightly custom navigation area where we can jump to where we are, where we want to be. And if I jump to one of those things, we have a kind of custom docked cell here that doesn't scroll, that gives us a sense of where we are in the materials, and some of the things to do with collaboration are over here. If I edit my account, I can decide which class I'm in and what my name is and so on. So all of that's really just standard pop-up menus and and palettes and so on. The next bit, we didn't do anything clever on. The custom learning apps, in the end, we used a boatload of manipulates and things using dynamic module with the dynamic controllers, and a few bits of custom code to make programming tasks easier without having to do everything low level. But there's nothing in that you haven't seen umpteen times before in other talks around the technology conference. The authoring process, as I said, posed a few problems in terms of coordinating the team. And so we went fairly early for the idea that we should have some kind of structured content template system. And so if I open up the authoring tools that we built here, we've got it's open in open mode. So we have a bunch of tools that we created for our developers to keep them on track. And the idea is that most of these things are just paste-in templates. So all they're doing is taking a set of notebook files, reading the notebook file in and inserting that notebook object into the current working cells. So I've got a new module here, and I fill in things like the title of it. I start a new chapter. There's metadata, which is used for our tracking purposes. So we have reports that can tell us which concepts have we hit, which concepts haven't we hit, which is the first module where a concept first arrived and was introduced. And so we can jump to that and say, did that really introduce the concept, or did it assume you knew the concept by that point? Which, when we were in a chaotic state of making materials, was quite hard to make sure that everything was ordered in a sensible way. So I can fill that stuff in as the author, and then I start putting in things like activities where it gets a bit more complicated. And my activity is to do something, and the modality is, maybe this is a discussion led by the teacher, so I'd say discussion, and then it's led by the teacher for the whole class, and it's going to take 5 minutes, and I fill in various things here. Maybe I'm not going to have any what to say, because this doesn't have maybe there's no manual, there's no manipulate on this one. But otherwise I fill in these things as the author. And that way we have a constant structure that we force. And then with that, we had a build system which takes these source notebooks and generates what you actually see as the output. So let me just save this here. Let's save that to something called temp. Oh, I've already got something called temp. Get rid of that. It obviously doesn't matter if it's called temp. And we do build current window, and we take those source notebooks, and by a process of symbolic transformation, I end up with the student version and the teacher version. And you'll see that the stuff that I've created for that activity has now been transformed into this much more elegant teacher guide that has what the purpose is, what the steps were, what to say. I ripped out the technical manual, so that's grayed out, there's nothing there, and what the answers were if I'd filled all of that stuff in. So we end up with a very consistent, recognizable format for the teachers. We got the student version. We've built indexes for all of the different modules so that all the menus work, and all of that's done just simply from the templates without having to worry about each author doing things differently. Another challenge we had was translation. So the CDFs, that's easy. I give that notebook to the Estonian translator, and everywhere they see English, apart from the metadata tags, which we forced into an uneditable state for them, they just type the Estonian over the top. Code presented a different challenge, though, because we couldn't expect our translators we were provided with, who were linguists, to know anything about code, and to know that when they see something like country data Estonia, the word Estonia in quotes is an argument and is not to be translated. But when they have something that's, say, a manipulate with the title of the cell being Estonia, that should be turned into Easti because it's supposed to be translated. So what we did was we created a fairly simple mechanism where every translatable string has this CBM translate wrapped around it in the source code. So you're looking here at the source code for the various packages behind the modules. This one's just doing some kind of panel of a dynamic module. I don't know what it does, but in it, it's got some words that the students are going to see. And so we wrap that with CBM translate. And then we have automatic scripts that pull all of those things out and generate a translation notebook, which the Estonian translator gets, which has English words, and then they type in on the right the Estonian words. And in this case, this red blob tells me that since the Estonian translator worked on this, that somebody edited the source code and changed this English string, and so the Estonian string needs to be revisited in case it's changed. Probably this said shoe sizes or something, and it looks like Kinga number, or it looks like it matches, but maybe it's changed from plural to singular or something, but some reason why that needs to be revisited. And then in the build process that I just showed, these things all get ripped out again and inserted back into the code. So now when you're in the Estonian version, the code is in Estonian as well as the source notebooks. Get back to my talk notebook here. Oh, I switched Mathematicas by accident, sorry. Here we go. So that's really just a kind of content workflow management process that we had to build, which would be applicable for any similar kind of project. The next thing was the question and answer feedback system that we built. So this was built up from scratch, and the idea was to come up with a question function. And it's a fairly simple function. We've got a question, here's the text of the question, and here's a list of answers, some of which have properties like true and false. And when we evaluate that, what we get is an automatically generated multiple choice question. And then I can, with its default arguments, I can pick an answer, check answer, and it scores me whether I'm right or wrong. And if I got it right, it marks it really right. But in the end, when we mapped it out, there was something like 15 or 20 different question types that we had to map to, and all kinds of different options. So we ended up building up quite a package here. So for example, if I give the same kind of question, but this time say question type goes to string, instead of multiple choice, I get a box that I have to type into, and I can check answer on that, and it goes red because I haven't matched the correct answer. And there's a whole question of what is close enough, and we have a tolerance option, for example. Here's one that's more of a graphical question. So I've got the question is a plot, and the correct answer is a particular point in space, and I've specified a tolerance here that I have to be within 0.1. So here I would say, what's the maximum? Check the answer, and it says that's correct. Or if I'd put it somewhere else, it would say it's wrong, as long as I'm within 0.1 in the coordinate system. And other slightly richer things like this freeform drawing question, draw a particular curve, and then the tolerance is the average distance from the curve. So that's going to be correct, but something like that is going to be wrong. So we end up with quite a range of these different question types, plus a whole boatload of options that have to be controlled. Am I allowed to reset it, or do I only get one go at the answer? When I'm finished, does it show me the answer or not? And we'll talk about collaboration in a minute. Things like how does it know what's right and wrong? Do I get an explanation of why it's right and wrong? Are there hints that can give me clues? Is there a time limit? Can I give more than one answer? Is there a maximum and minimum number of answers, and so on? So there's quite a package that was built up there that we hope to reuse heavily. And maybe, for example, if I add some options to this one and say max answers goes to 3 and min answers goes to 2, for example, you'll see the question changes radically. I immediately get 2 possible answers I can give, and I can add more answers, but only up to a maximum of 3, and I can go back down again, but not below the number that was my minimum. And likewise with the image spot, I can put multiple spots down or up to the maximum, and have to give the minimum before I'm allowed to submit the answer. So there's quite a bit there in some of these more subtle things, like how does the question score if it's not just simply a right or wrong answer. And that's a bug, which I should note. That should not be in the option value. Okay, another thing that we wanted to do, again, this was for this particular project, was the decision as we were hired to build the curriculum was it had to be teacher-led. We're not trying to, well, it was a bit subtle. The idea was that we had to do it so that the teacher didn't have to have any skill at all, but the teacher was still going to be in the classroom leading it. So it was a bit of a balance that we had to kind of treat them like idiots, but not cut them out of the process. And so what we came up with, you've already seen, was the idea that we have teacher guidance things that are built in, which a good teacher will ignore and will just kind of elaborate around in their own way. But for a low-quality teacher, we had it right down to a script, although this one seems to be missing the script, but some of them have literally what to say to lead a discussion, what questions to ask, and what prompts to give, and they're kind of led through with a script. But by packing it down to something very small, which is even collapsible, almost out of sight, we wanted something that didn't get in the way of the core material. Another part of that was we were told, although we were a little misinformed about the technology, but we were set at the design that most of the teachers had a 2-screen setup. So here I'm mirroring, but the idea is in most classrooms, all of that teacher content would be on a private screen that only the teacher saw, and that what they were showing to the students would be on a separate screen. And so we built in a mechanism for that, which we use some places in a kind of very precise controlled way, but in other places it's just kind of throws itself up here as a little prompt that says, supposing this thing was it in my teacher notebook, I want to make a point of talking about this. The idea is that I can just click on this thing that appears as I mouse over, and it throws it to the full screen. And if I was on my private screen, it would know that I had 2 screens and would only jump to the other screen. Here I'm mirroring, so I'm seeing the same thing as you. And there's a kind of swap to the other screen if the defaults were the wrong way around, if actually my screen is big and the as it turned out, we found this the hard way. Sometimes the screen that the teacher had was the big one, and the projector was 640 by 480 pixels, and so the initial design got it the wrong way around, assuming the small screen was the teacher's, and had this screen went always to the wrong one by default. But again, it remembers where I've chosen once I've swapped it. Another key thing was collaboration. Actually, let's jump to the materials here to show this in its actual context. So particularly for data, we wanted the ability to share data around the class. And for that, we built a mechanism where I'm in the teacher version here, so I see both the question and a responses tab. The student version only sees the question. And the idea is that I can pick some value. What am I asked here? On a scale of 1 to 5, how confident are you? So I'm giving a vote. And I pick my value. And this is just a question framework thing. But this time, in the options for the question, instead of the completion action being show whether you're right or wrong, this particular question has no right and wrong, it's an opinion. So the arguments that set it up just simply said values 1 to 5, it didn't say what right and wrong is. The completion action was set as a send to server, which means instead of a kind of am I right button, I get a send button, I hit send, and that has now been sent to the teacher. The teacher viewer gets to look at this and see who's in the class, and I've got a bunch of test people in the class here, and I've just voted, so my score is showing up as green. Conrad's in the class, but has obviously walked off and not decided to vote on this question. So we're waiting for his answer, so we can see whether or not who's in and who isn't. And at this point, I can have a look at either a particular response, see what did I say. I voted 4 on this. Or I could go to all responses and show a summary, and here's the breakdown of the summaries. And these things are adaptive. At the moment, we want to have a richer system where I can specify what it does. At the moment, it just kind of intelligently says, well, there's a bunch of values here that are categorical, so let's put them in a pie chart and a bar chart. And it's up to me as the teacher to go, pie chart's the one I want, so I'll click on that, and we get to the full screen mode now that says, here's your votes, kids, what does this mean? And we have a discussion around it. So the way we implemented that, I toyed for 2 days trying to do an ad hoc peer-to-peer network over MathLink, and it's an exercise in not using the wrong tool for the job, because after 2 days it was still unstable and was bending my mind. So I switched to a much more sensible server-client model. So we set up a webMathematica server, and what the collaboration system does is it bounces the information to the webMathematica, whose job is only to store it and serve it up on requests. So behind the scenes, there is a bunch of developer tools, if I go back to the talk here, that look like this. It's a call CBM server command. It's got a handful of actions, things like put, get, append, reset to clear an activity. There's a bunch of management things like authenticate, if I have to have a password, and reset password and things like that. But the main ones are just basically a put and a get. There's an activity ID, which corresponds to the question we're answering. A payload ID, which is usually answer, but sometimes we send a score, sometimes we send some other information and we need to keep them apart, and then a payload. So it's making a URL fetch kind of call to the webMathematica server, and the server just simply says, here's the payload, stick it in an SQL database along with the various metadata that came with it. And then I can do a call CBM server get, and this is how the teacher viewer works. It just says, for all of the things on this activity in that payload, show me what's in the server, and it gets the answers back. And so behind the scenes, I can manipulate that, can be polling the server once every couple of seconds and pulls these things back. And this is one of the nice things about Mathematica having a serialization for every kind of object, is that here I sent not a string, I sent square root of 2. Now it happens to be stored on the SQL server as the full form as a string, but what that means is that anything I can represent in Mathematica, I can send to the collaboration server. So I can send all kinds of objects backwards and forwards. So here if I send a plot, the collaboration server now can serve up the fact that one of the answers was a plot. So when we have questions like that drawing question, not only can I send to the server whether the student got it right or wrong, I can send the actual plots that they drew to the server, and we have some activities where what the teacher gets is, here's all of the plots shown together, or here's an average of the curves that you drew to get a kind of class average shape, which would be impossible to do without sending backwards and forwards actual sort of structured symbolic objects. And in richer forms, there is more data behind the scenes, so I can see things like when it was submitted and who the submitter was and their name, real name and their ID. And we've got a little bit more to do in terms of kicking people out of the class, which we found, or ignoring students, which is a bit of a problem, because if somebody puts a stupid answer in and you've got an automatic plot, one outlier where somebody's typed in 100 billion as their vote suddenly squashes the plot down. So we need a little bit more in terms of the teacher control. But behind the scenes, it's this really simple function that's simply bouncing things off a webMathematica server. So we did the first pilot, and we're about to go to second pilot. And some of the results were very promising. The collaboration scaled very well. The decision to put an SQL database behind it was very good for scaling. So we currently have 350,000 plus answers that have been submitted by students through the process, and it still responds in, well, we got the scaling, but at peak it's been doing about 30 queries a second, and as I say, about 350,000 queries over the 6 months of the trial, when the database is still building up and it's still responding in typically about a second to get the answers back. So I'm pretty pleased with that, especially as the original prototype took just an afternoon to write. That I had, before feature creep stepped in and we started having things like password privileges and whether you're a teacher or a student and whether you're allowed to reset things. The basic idea of pinging off a webMathematica server was about 2 hours work to get the client and the server code working. So it's nice when you use the right tools compared to trying to shoehorn the wrong thing. The user interface wasn't so good. The lesson here is a lesson that I should have learned from Apple and Steve Jobs long ago, is keep it simple. We had a slightly fussy interface. You saw a glimpse of it, actually. Stephen gave a glimpse of the computer-based math materials, but he actually used the previous version, which was just a little bit more cluttered with slightly more bits and bobs around it. And what we've done is slim things down a bit more, put everything into one window instead of multiple windows, and just keep it really simple. And that's now going out to the second pilot. So I end with just really one question. We're going to keep building this stuff because we've got other projects on the go and we're going to continue to develop it. But it is an open question, really, which we don't have time to discuss now since I've used my time, but I'd love to talk to you out in the corridor maybe, is this stuff actually more generally useful? Should it be productized in a way that says, here's a complete kit for building computer-delivered CBM content? Are just bits of it, like the question framework, something that we should productize and put into Mathematica or some kind of application? Or is this just interesting to watch, but nothing of interest to the rest of you? I'll leave you to come up and ask me afterwards, because I'm on the end of my time. Thank you very much.